Hi everyone, this is Mrs. G. I'm sorry that I'm out today. I'm home with my sick child who has a very high fever, but I hope I will be back tomorrow for our double period. This is the worksheet that we started yesterday in class, and I'd like to make sure you have it out. So if you need to pause the video and take it out, please do that right now. Hopefully you have it now there with you. Basically, what we did yesterday in class is we did these four, yes? And we talked about graphing them. These work really well to graph because primarily they're solved for y here. You have y equals. That makes it easy to graph. If you got stuck here in number 4, be aware that we can manipulate our equations. We can move things around. We can change the location, kind of, I guess you could say, of certain terms. And so this one is nice and easy because it starts y equals 2x. You're going through 0 up to over 1 up to 1. You can see how that would work, right? This one is a little different because it doesn't start y equals. Okay, all you have to do is understand that working with equations, you do the same thing to both sides. So minus x on both sides of our equation. These x's here kind of cancel out. What you're left with is y equals negative x plus 3. That's obviously the same as y equals 3 minus 1x. It doesn't really matter, but as you can see from this situation, you now have m equals negative 1 over 1, right? Coefficient right there, and c equals 3, and you can graph that. So if you got stuck on number 4, I hope that's a little bit of a help for number 4. But what I want to talk to you guys about today is the rest of the worksheet, and maybe coming up with a way that's a little quicker, a little bit less tedious than some of the graphing. I like starting out with graphing because it helps make sense of what you're doing. Okay, it's really good to practice. But once we get the hang of graphing, let me see if I can show you a little bit of algebra that will help us go just a little quicker with this. Okay, and it's not it's not a short process. So I've written out some really detailed steps here. Okay, so take the time now to put this in your math notebook. It's going to need a whole page. Let's really kind of go step by step through the idea of solving systems or simultaneous equations, whatever you want to call them, by substitution. Okay, so if you need to pause and write down your title, do that, and then come back to me. There's 5 steps here. Okay, the first step here is in green, so I will go to all green. Okay, so it's kind of a nice topic to do by video because you can pause and you can come back. So here's step 1. And you could just follow along and then go back and write it down if you want. Choose one equation to solve for one variable. So solve one equation for either variable. If you look up here, this is my example. Okay, right here is my example problem. Okay, I have these 2 equations. I have x plus 4y equals 6, and I have x plus y equals 3. Yes, we could graph them. Yes, we could see where they intersect, but let's see if we can be a little faster with this. Now, there are essentially 4 variables, right? There's an x and a y and an x and a y. I'm going to pick one of them and try and make the equation have x equals or y equals. Make that variable alone. Make this one alone, that one alone, that. Pick one. You choose, and that's sometimes what makes this difficult is you have a lot of choice in the matter. So I'm going to choose the first one just because that seems to work for me. And I'm going to say, okay, x plus 4y equals 6. I want to get the x alone because if I try and get this y alone, I'm going to have to also divide by the coefficient of 4, and that makes my life more difficult. So why not make life easier? Okay, you're going to subtract 4y to the other side, and you're going to get x equals 6 minus 4y. You could write negative 4y plus 6, but it doesn't really matter. Okay, so I've written that out so you can see, but basically, it's exactly what I have here in this green box. Okay, I picked this first equation, and I solved for x. Okay, why x? Because that one just seemed the easiest to me. There were many options. If it feels confusing, just go with me and listen, try it out. I'll be back tomorrow to answer your questions if you have them. But just try and have an open mind and give it a try. Okay, so here in green, we have right here, step 1. Okay, solve one of the equations for one of the variable. Okay, to solve for means to get that variable alone. X equals blah. Okay, that's step 1. Step 2 is here in purple. Okay, substitute this expression right here, which I'm underlining in purple. X equals 6 minus 4y. So we take the 6 minus 4y. Let me see if I can show you the little color. We take this entire piece right here, and we put it there for x, up there, in the other equation. Okay, so it's got to go into the other one, otherwise you haven't used your other information. The other information is coming from the fact that we also know that x plus y equals 3. So in this equation, x plus y equals 3. Take out x, that's why it's called substitution, and put in 6 minus 4y. Okay, that's just how the process works. We want trying to figure out where the lines intersect. We're trying to find that one solution so we can substitute each equation into each other. Okay, so just to recap, if x equals 6 minus 4y, in the other equation, take out x and put in 6 minus 4y. And there's a reason for that. The reason for that is, okay, right here, I have one equation with one variable, with one letter. So I can solve this, just like I've been solving equations with one letter since the beginning of 7th grade. Okay, what we did first here, maybe you want to go back and write that down. Okay, sorry. So step 3 is to simply solve the equation. I call it a composite equation, but you don't need to know that word. Solve the equation for the one variable. Okay, so here it is in red, step 3. Okay, so that goes there. Maybe I should just keep it easy. Okay, here is step 2 in purple. Okay, so step 3. The first thing we can do is put together like terms on the same side. So we have a minus 4y and a plus 1y makes minus 3y. Okay, so that's the first thing we did. We subtract 6 to both sides, here and here. 3 minus 6 is negative 3. And then last but not least, we divide. Divide by negative 3 on both sides, so y equals 1. You have found half of your answer. It seems like a lot of work, but you're only halfway done because you have figured out the y coordinate. Now, it's the hard half. To figure out x, it's much easier. Okay, so to figure out the x that goes with that y, because remember, you're looking for a coordinate. Your final answer is x comma y, where, I don't know, it's 3 comma 4. Okay, so your answer is a coordinate. Okay, your answer is an x and a y. Let's see, once I know that y equals 1, step 4 over here says plug in the resulting x or y value into one of the original equations and find the missing piece. So go back to where you started. Okay, once you know that y is 1, go all the way back up here. Pick one of the equations. Pick the easier one. It doesn't matter which one. To me, this seems like a much simpler equation. X plus y equals 3. So therefore, if y equals 1, what does x have to equal? If x plus y equals 3 is one of my equations. And again, it doesn't matter which one you pick. Just pick the one that seems easier to work with. Put in y of 1, just like that. Okay, put in the answer that you just got into this equation. And you'll see that it's pretty easy to figure out what the x that has to go with it. So x plus 1 equals 3 here. X plus 1 equals 3. So therefore x has to be 2. And that is your final answer. Okay, I know when you look at it for the first time, it might seem a little more confusing than graphing because we've been practicing graphing for a long time. But as you get good at this, it's a lot faster, I think, than doing your y equals mx plus b and doing all the graphing. Okay, step 5 is just to say, hey, that's your answer. Orange. If y equals 1 and x equals 2, 2 comma 1 is my answer. Okay, so that is step 5. Okay, the two values will be the intersections of the lines, and that's done. You could plug those both in and see if they work, but that's how you run substitution. Okay, I know I've written all over here, but feel free to stop, write this down. Get it all nice and neat in your notebook. If that's the only thing that happens today, because this seems really confusing to you, that's fine with me, because then when I come back, we have it in our notes and we have a starting point. Okay, so feel free to pause and put this all in a nice and neat sort of way. Add some color, it helps. All right, if you're back from doing those things in your notes, let's go back to this worksheet here. Okay, I want you to try number 5, because hopefully you've done number 4 already, in the substitution method. And hopefully you do the rest of the worksheet. Okay, that's kind of my plan for the period, is you'd finish 5, 6, 7, 8, and 9 trying the substitution method. So number 5, I'm going to write it over here. X plus y equals 0, and 3x plus y equals -4. Oops, and you know what? I'm sorry, changed my mind a little bit. I like them next to each other. For me, it just works a lot better. So I'm going to squeeze this in a little bit. So 5 is x plus y equals 0, and 3x plus y equals -4. I need to get one of the variables alone. I'm immediately drawn to the fact that this seems like a much easier equation. X plus y equals 0. Not a lot of complex things. This has got a coefficient here. There's 3. That seems to be a lot to deal with. -4 versus just 0. So let's just kind of look at our simpler equation, and let's pick one of the variables and make them alone. It doesn't really matter which one. Makes no difference. Why not just choose x? It's the first one. So step 1 is to solve for one of your variables. Okay, on both sides of your equation, you're going to subtract y. So x equals -y. Okay, that is step 1. Step 2 is to take this information and put it there. Okay, instead of writing x, we write what we know x is equal to in terms of y. Okay, so my equation is 3x plus y equals -4. That's the same thing I have up here. I'm just rewriting it. And instead of x, I write -y. And then I ask myself, 3 times -y is got to be -3y plus y equals -4. And I'm in a pretty happy place right now because I have one equation with one letter. I can solve this. Okay, from there, we're just going to put together our like terms here. -3y plus 1y is -2y equals -4. Divide by -2, and you have figured out 1/2 of your answer. You've done a lot of the work. You've done more than half the work, but you figured out half of your answer. Because we're looking for the point they intersect. Okay, so -4 divided by -2 is +2 if you hate to hate your lover, okay? So, what's x? Go back to your original equations. Okay, what does x have to be that corresponds to when y is 2? It doesn't matter which one, because your answer has to be a solution for both. Again, I'm drawn to this one because it seems like a lot easier of an equation. X plus y equals 0. So if y is 2, what does x have to be in order to make 0 when you add them together? Well, don't overthink it. You could subtract 2 from both sides, but it's got to be -2. So that, my friends, is your answer. -2, 2. And there it is. All right, try the next 4. It's not easy, but give it a go. Okay, number 6 is not so bad because you already have solved for x. I would take that piece and put it right there in the other one. Okay, this one here, a little more difficult. I think it's probably easiest to solve for that x by minusing 2y on both sides. Well, this one's quite sneaky. Don't overthink it, just -2 in there. And then this one's already solved for y, so plop it in there. Don't forget, distributive property times x plus 2 equals -15. Okay, that should be what you need to finish the worksheet. There are more difficult worksheets if you do happen to finish this one. They're on the table in front. Good luck, ladies and gentlemen.